So a couple things on this page. Both of these can be used to solve non-right triangles. They can both be used to solve right triangles too. So I'll see people use law of sines on right triangles. That's fine. They work for anything. This right here, the second bullet point, talks about the ambiguous case because law of sines can't It can't distinguish between acute and obtuse angles because it's positive in both quadrants, which is what we talked about last class and in the homework. Law of sines, you have to check for the possible ambiguous case. The third bullet point basically is telling you law of cosines, there is no ambiguous case because in all students take calculus, cosine is positive in first quadrant, negative in second, so it can distinguish between the two. So the last bullet point is really what matters to us. When solving for the angle, if there's any possibility that the angle you are solving for is obtuse, do not use the law of sines. If you stick to that, then you will mostly, unless I force it, avoid the ambiguous case. Okay? So if there's any possibility the angle you are solving for is obtuse, do not use the law of sines. So today, a lot of what we're going to be talking about is, first off, knowing when to use each law and when it's wise to use each law. Sometimes you'll have the option, and sometimes one will be better than the other. Sometimes you can stick with using the easier law of sines as long as you are being careful. Okay? So a good example of a question where you can avoid the ambiguous case is example 3 here. Okay? The ambiguous case, let's review that for those who don't remember. Only have to watch out for that when you're given what? Two sides and an acute angle. So does question 3 fall under potential ambiguous case? Yes, it does. Now, question 3 could possibly be ambiguous case, but someone tell me why I can't use the law of sines here.
Well, if the greatest, like the angle, like the, you can say like the largest side has the greatest angle across it, and so it's 15 is bigger. It's like a pretty big side, and I don't know.
So I want to be careful because I can still find an obtuse angle. The other reason I cannot use, like actually can't use the law of sines here is because I don't have an angle side pair. So it's not even possible for you to use it here, but it's not a good idea to use it either. All right? So I really should use law of cosines when possible to avoid the ambiguous case. So let's use what we have. Which version of the law of cosines are we going to use based off the angle given? A squared version based off of angle A here. All right, so quick review, law of cosines formula looks like this. Remember we said the side has to match with the angle at the end, and then these pieces in the middle you fill in based off of the other two sides. It's always in the same pattern, but not the ones that are used on the ends. So I typically write out my formula first and then plug in what I know. This one says solve for all missing parts, so we're going to start by finding side A. Take a minute, plug in your numbers to B and C and cosine of A, and type it into your calculator. Everyone does need a calculator. I really want you actually doing it because if you don't, you'll run into stupid things on your tests and quizzes, and you'll want to know why you're not getting answers. It's because you haven't actually practiced typing it in. Couple quick reminders about typing this in. Remember I told you the less steps you use in your calculator, the better. We ran into that in first period. Some people are trying to do 15 squared plus 6 squared, then type in other parts of it, and they're missing numbers, like randomly missing that 2. That'll throw the whole thing off. So just type the whole thing in at once and then square root your answer. Any issues finding A? All right, now this said solve for the missing parts. What is still missing? Angle B and angle C. Now, here's where we have to be careful. This is still potential ambiguous case. I still have 2 sides and an acute angle. Now, I have 3 sides, but that hasn't helped me with the whole angle situation, okay? I can do one of two things, okay? If I want to solve for angle B, think before you answer this one. If I want to solve for angle B right here, what law should I use? B is which side here? The largest. Therefore, angle B is going to be the largest angle. Should I use law of sines if B could possibly be obtuse? No. So if I want to solve for angle B next, I need to use law of cosines. However, I said if I want to solve for angle B next. Look at the three sides. C is the what? Smallest. So if I'd rather do the easier version and use law of sines, I just have to solve for angle C first. Okay? So you have two options. If you want to go for B, solve for it using law of cosines. Or if you want to do C, do law of sines. I prefer to save myself work, so I get smart about it and do sine of C over 6 equals sine of 50 over that 12.05, which I probably would use the answer key in my calculator because I've just found that 12.05. Cross multiply and take the inverse sine real quick. All right, so you get about 22 degrees for angle C, making it super easy to find angle B because what do you have to do? Just subtract the other two from 180, which means you get B is left over with how many degrees? 108. That would have given you problems if you had gone after finding angle B using law of sines. Angle B using law of sines, they would have given you an acute angle, and that would not have been the correct one. Okay? The other examples we are going to do will be over on page 97. 97. On page 97, we're just going to look at 1, 2, and 3. Actually, no, we're not. At the moment, I want you to look at 1, 2, and 3. And I don't want you to solve anything right now. On 1, 2, and 3, I want you to look at each one and tell your people at your tables which law you would use first. On question 1, we agree we should use law of sines because we have what?
Two angles.
Two angle and a side, which means we're not in an ambiguous case. We don't have to worry about it. And we have a pair. Okay? Question 2. What should you use to start with?
Cosine.
Cosines for 2 reasons. First reason being you have no angle side pair, so you can't use sines even if you wanted to. Second reason being we're in the potential what? Ambiguous case. All right. I want everyone to, after we talk about 3, on question 3, what are you forced to use? Cosines, because what reason? No angle side pair. All right. I want you to do question 1. The first thing that you would do in question 2, which is finding side C. And then let's talk about 3 real quick. You have to use cosines. You have an option here. And there is a right answer to this question. Which angle do you find first in 3? You're already using law of cosines. Which angle do you find first? C. Why? It's the biggest. You're already using law of cosines. Get the biggest angle first. That eliminates what? The ambiguous case. If you get a smaller angle, you might still be in the ambiguous case. Don't do that to yourself. Get the biggest one first. That forces the other 2 to be acute. You know that's going to be how it is. Okay? So I want you to just now do all of question 1. Find the first blank, which is side C in question 2, and find you can do all of question 3 after we set that up. I think to myself and change my mind. All right, so in 2, we found side C. Hopefully you got side C is about 2.46. That one in particular is very easy to leave it at its a square or c squared version, because I think c squared was like 6 point something, and it's a very logical number. It just isn't the right answer. So be careful with that. Now on this one, this is still potential ambiguous case. Why? Because one of the other angles left could still be obtuse, right? So, again, two options. This is like the example we did together, okay? You can just stick with law of cosines and solve for the bigger angle, which would be B. If I want to use law of sines, which one do I have to solve for? The A, right? So if you want to use law of sines here, you've got to solve for A.
What would happen if we tried to solve for B?
You're going to run into the ambiguous case.
How do you distinguish that we need to solve for A?
It's the smaller side.
Okay.
Therefore, it's not going to be the obtuse angle. You can't have two obtuse angles, right? So if you eliminate the one that could be, then solve for the other one. So this one I would do 6 times the sine of 20, divide by 2.46. And then I would do inverse sine of that decimal to get my angle A, which I get about 56 or 57 depending on whether you rounded the 2.46 or you use the answer. Mine rounds up to 57. And then how do you find angle B? Subtract from 180, which gives me 103. Since B is obtuse, that does tell me that if you had solved for B using law of sines, you would have gotten wrong answers, because usually that means you didn't recognize the ambiguous case.
If I
Yep.
get like 105 degrees Celsius, that's still fine.
105 what?
105 because I rounded up to 2.5.
For like right now, it's okay, but you need to keep the sides at 2 decimal places, because that'll keep you within a degree, and then you'll be fine. Okay. All right. Does that kind of clear up how to avoid some of the problems a little bit? All right. We're going to flip over a page and do one word problem. Then you'll have homework time. We're not going to do questions 1 and 2 here because these are right triangle word problems. The next set of notes we do, which is not Thursday, but the next Monday for y'all, it will be right triangle word problems. Just question 3. So we are just doing question 3 on the back here. This country has launched their 2 satellites. We've got an astronaut going up, Ivan the astronaut. As he approaches the 2 satellites, he finds one of them is 8 kilometers and the other is 11 kilometers from his. The angle between the 2 with Ivan as the vertex is 120 degrees. How did I know that this was a law of sines, law of cosines problem? It's not what kind of triangle? A right triangle. Clearly because of the angle that they've given to me. All right, so we draw ourselves a little picture here. You're going to see my excellent artistic skills. Here is my Ivan the astronaut with his helmet. Ivan the astronaut is 8 kilometers from one satellite. So here we go. Here is the one satellite, 11 kilometers from the other. Can I say that word, kilometers? That'd be great. Okay, here's my satellites, which look remarkably like something off of Star Wars. We would like to know how far apart are they. So they're asking for that distance, which nicely completes my triangle. We said this one was 8 kilometers away. This one is 11 kilometers away. Where is my 120 degree angle? In between them, right with Ivan as the vertex. You may label your triangle however you like. Since Ivan is an astronaut, I am labeling him A astronaut, or B and C over here. Which means, let's discuss what information do we have. We have angle A, right? And then which sides do we have? B and C. Side B is what? 8, and side C is 11. Therefore, based off of that information, can I use law of sines or law of cosines? Cosines, because I do not have what? An angle side pair. I also use the version based off of the angle that I am given, which means I use the a squared version. Take a minute on your own. This case, we're solving for side A because that's what they asked for, the distance between the two satellites. Should just take a minute. Plug that in your calculator. Check your answer there. Just remember, in terms of reasonableness, the other two sides are 8 and 11, so you want something kind of within that range. It is the biggest side because it's across from the biggest angle, but still keep it within a reasonable range here. Rounded 2 decimal places. Any issues? All right, 2 parts to your homework on this one. First is page, let's see. No, you do the square root of that because it's a squared. So your homework is the following: 101 and 102, 1 through 6. On pages 103 through 105, we are just doing 2, 4, and 5.
Oh,
Just 3 questions.